In 2001, scientists studying a speck of zircon from Western Australia, no bigger than a grain of sand, found something that shouldn't have existed. The crystal, recovered from a dry sheep paddock in the Jack Hills, was dated to 4 billion years old. That alone was extraordinary. But locked inside its chemistry was a clue pointing to something stranger still: liquid water, and not on the Earth we were taught existed then. A molten hellscape so violent that scientists had named that era the Hadean, after Hades itself. A single crystal was quietly rewriting the opening chapter of our planet's story. Because here is the paradox at the heart of Earth's history. Everything about our world's origins suggests it should be barren rock. And yet, within a few hundred million years, it was capable of oceans. Not long after that, it was capable of life. By the end of this film, you'll understand how a ball of molten debris became the only world we currently know to host life. Why the very air in your lungs was once a global poison, and why the deepest secrets of our planet's past were pieced together not by astronomers, but by geologists who had to fight, sometimes literally, to be believed. Because this is not simply the story of how Earth was made. It's the story of how many times it should have died and didn't. Picture the solar system 4.6 billion years ago. A swirling disk of gas and dust around a newborn sun. No planets yet, only rubble. Gravity pulled that rubble together, grain by grain, until Earth existed as a sphere of molten rock, bombarded constantly by debris still falling from the disk. Then came a moment of violence almost too large to picture. An object roughly the size of Mars, astronomers call it Theia, struck the young Earth at a glancing angle, very likely liquefying its outer layers and hurling a ring of vaporized debris into orbit. That debris eventually coalesced into the moon. We are, quite literally, living beside the wreckage of our own creation. That should have been the end of the story. A scorched, dead world circling a scar in the sky. Instead, something settled with startling speed. Zircon crystals, like the one from the Jack Hills, suggest Earth may have had stable crust and liquid water within a few 100 million years of forming, far sooner than scientists once assumed. And in those early oceans, chemistry crossed a line no one has ever fully explained. It became biology. We still don't know exactly how. Researchers have proposed hydrothermal vents on the ocean floor, tidal pools on volcanic islands, even the raw ingredients arriving from space aboard comets. Serious hypotheses, none proven. What the evidence does show is a timeline. By 3.5 billion years ago, and possibly earlier, microbial life had taken hold. And then, for almost 3 billion years, roughly 2/3 of Earth's entire history, almost nothing seemed to happen. No plants, no animals, nothing visible to an eye that didn't yet exist. Just single cells, quietly, patiently, preparing the most dangerous chemical revolution the planet had ever seen. One of those cells learned to split water using sunlight, releasing oxygen as waste. It sounds harmless. It nearly ended life on Earth. To the organisms alive at the time, oxygen wasn't the gas we depend on. It was a corrosive poison, and its sudden buildup around 2.4 billion years ago triggered what may have been the planet's first mass extinction, caused not by an asteroid or a volcano, but by life itself. The element every animal now needs to breathe began its career as a toxin so severe. It very nearly finished the story before it began. The planet's near misses didn't stop there. Around 700 million years ago, ancient glacial rock found even near the equator suggests Earth may have frozen almost entirely, ice sheet to ice sheet, a hypothesis scientists call Snowball Earth. And then, not long after that global deep freeze thawed, something extraordinary happened. Within a geological blink, around 541 million years ago, complex animal life exploded into diversity. Trilobites, early arthropods, the ancestors of nearly every major animal body plan alive today, appearing in the fossil record, so suddenly it's simply called the Cambrian Explosion. A frozen, nearly sterile planet had somehow become a nursery. For most of human history, nobody could have told you any of this. The accepted timeline of Earth came not from rock, but from scripture. Most famously, Archbishop James Ussher's 17th century calculation, placing creation in 4004 BC. It wasn't foolishness. It was the best method available in a world without radiometric dating. The shift toward deep time came slowly through geologists like James Hutton, who studied layered Scottish rock formations and proposed something radical, that the forces shaping Earth today had been running not for millennia, but for ages beyond easy imagining. The final piece came from an unlikely, stubborn figure. In 1956, geochemist Claire Patterson set out to do something narrow and technical: measure the radioactive decay of lead isotopes in ancient meteorites to calculate Earth's precise age. He succeeded: 4.55 billion years, a figure that has barely moved since. But the same experiment that gave humanity its answer also exposed something Patterson hadn't gone looking for. Lead levels in his samples, in the environment, in human bodies, were far higher than they should naturally be. He traced the contamination to a single source: leaded gasoline. Patterson had just discovered an enemy far closer to home than any asteroid. And the oil industry, whose product was the source, tried to discredit him and cut his funding. He spent much of the rest of his career fighting a public battle against an industry worth billions. He largely won. Leaded gasoline was eventually phased out worldwide, a public health victory that began, almost by accident, with a man trying to date a rock. With Earth's timeline finally secured, the fossil record laid bare its darkest chapters. Life has endured multiple mass extinctions. The worst, 252 million years ago, wiped out by some estimates over 90% of marine species. A catastrophe so severe it's known simply as the Great Dying, and likely triggered by immense volcanic eruptions in what is now Siberia that poisoned the oceans and choked the sky. Life came astonishingly close to starting over from almost nothing. The most famous extinction is also the best understood. 66 million years ago, an asteroid roughly 10 kilometers wide struck the Yucatan Peninsula with the force of billions of nuclear weapons, ending the age of the non-avian dinosaurs, and clearing the way, almost incidentally, for a handful of small, nocturnal mammals hiding underground. Those survivors had no way of knowing what they were inheriting. Tens of millions of years of quiet evolution followed, branch after branch, until one lineage of primates in Africa began doing something new: making tools, controlling fire, telling each other stories about where they came from. Every mythology humans ever built to explain Earth's origin, floods, fire, divine breath, was, in its own way, reaching for the same answer that crystal in Western Australia would eventually give in cold isotopic fact. Which brings the story back to that fragment of zircon, no bigger than a grain of sand, pulled from dry Australian dirt. It had survived the Hadean. It had survived Thea's impact, the oxygen catastrophe, Snowball Earth, and the great mass extinctions that followed, sitting quietly in the ground while empires rose and fell above it, waiting 4.4 billion years to be found. Earth itself did the same. It was struck, poisoned, frozen, and nearly sterilized, and each time, something in it kept going. Not because survival was likely. Because, against every reasonable expectation, it happened anyway. And somewhere on that ancient, battered planet, a species eventually evolved that could hold a piece of its own beginning in one hand, and finally ask what it meant.